Okay, so the title of this presentation is Test Environments for Large-Scale Software Systems. And this is a presentation of a recent study from Software Center Project 6. My name is Torvald Mårtensson, and I've conducted this study together with Göran Anker, also at Saab, and Daniel Ståhl, who is at Mårtensson and Linköping University. Okay, so let's continue with the presentation. And so what is then the takeaways from this talk? We'll talk about, as Christian said, a list of intrinsic and extrinsic success factors for test environments. We'll see that there is no such thing as pure software when it comes to test environments. And finally, we'll see how test environments are a vital part of the continuous integration and delivery pipeline. Just a few words about the background and purpose for this study. And in our previous work, which also is a series of studies within the context of Software Center, we have multiple times touched upon problems and challenges related to test environments. And so we wanted to examine this field of research in a more structured way. So we conducted this research study with a research question: what are the success factors for test environments that can enable efficient and effective testing of large-scale software systems? And this study was conducted in 4 steps. We started with the first step, which was a review of published literature. We then moved on to a series of interviews with one of the case study companies. And so we conducted a large series of interviews with participants from that company. We had focus groups, so that workshops with focus groups with each of the other 4 companies. And finally, a cross-company workshop with the participants from all the participating 5 companies in the study. And the different approaches for the steps in the study were purposely selected to allow method triangulation. The study included 5 companies, and we had a quite high number of participants in the different steps. There were 30 individuals in the first series of primary interviews. We had in total 31 participants in the focus groups and 30 participants in the cross-company workshop. And as you can see, the companies operate in different industry segments, but they all, the product in all cases is a large-scale and large-scale and complex software system, but also with connections to mechanical and electronic systems. Okay. And for the interviews and the focus groups, we had the same questions, and we asked the participants to start with how did they like their test environment as at their current shape. We also asked them what they would like to change in order to make the test environment more efficient or to enable more efficient and effective testing. And then we also asked what would they like to change in order to cope with future challenges from future development projects. So what would they like to change in the test environments? And finally, what additional challenges did they think came from both large scale and also from this connection to hardware that were evident in all of these companies. So the connection to the interfaces to mechanical and electronic systems, what kind of challenges came from that? Okay. So the primary contribution from this study is this list of success factors for test environments that can enable efficient and effective testing of large-scale software systems. And we split this list of key factors or success factors in 2 groups. And the first group, showing to the left, are the intrinsic success factors. And that is success factors that are more or less fully inherent in the test environment. So they can be found, you can solve the problem in the test environment itself. That could be, for example, the capability to test cybersecurity. To the right-hand side, you can see the extrinsic success factors, and that's the factors that fully or almost fully are outside the actual test environment. That is, for example, the ability to expose debug information in the system under test. And so if you're responsible for implementing a good test environment, you must work with the intrinsic success factors to the left, which are how you fix, more or less, set up your test environment. But also you must influence other parts of the organization in order to make changes in, for example, the product, organization, etc., to be able to make a good test environment. So let's walk through this list of key factors. We don't have so much time, but I will try to give at least one example of so you understand what each of these factors is about. Up to the left, you can see the first intrinsic success factor, which is then test environment capabilities. And that's about all the things that you want to do in the test environment. For example, if the product is a car or some kind of vehicle, you want to start the vehicle and then drive around. But you also want the capability to test with fault injection in order to test robustness. And you also want to test the performance, etc., which in that case, you probably need hardware availability. So there are also some certain aspects that you must take into account in order to have the test environment capabilities that you want. So that first factor is very much about effectiveness in the way that you can do everything that you want to do in the test environment. The second factor is more about efficiency. To have the capabilities is not enough. The test environment must also be easy to use and you must have test environment usability. If you're into manual testing, it's about how you can present status for what's happening right now in the product and also in the test environment. If you more rely on automated tests, it's more about how you visualize your data after that you run a set of tests. So the second factor is about usability, more the efficiency for how you run tests in the test environment. And the third factor is then about test environment stability. And that's about how you should be able to expect the same result for every time that you run a test, at least when it comes to the test environment, because you can have instability in the product as well. So hardware stability is then that you shouldn't have problems, for example, if you switch between configurations, that you don't know that you have the right configuration, hardware configuration. And it's also affects software stability. For example, you shouldn't have the case that if a software process crashes in your simulator, it shouldn't make you so you have to rerun the whole set of tests. So the factors to the left, the intrinsic success factors, are test environment capabilities, test environment usability, and test environment stability. To the right, we have the extrinsic success factors, and that starts with product testability, which is primarily about observability and controllability in the product. And so that means that you should be able to expose, for example, the bug information in the product, and that you could be able to control what happens in the product, so you can work with, for example, fault injection when you test. This is also connected to separation of concerns. And if you have an architecture with a high level of separation of concerns, that means that each component in your product does more or less just one thing and have a clear purpose. Then it's much easier, if you can see a problem, it's much easier to isolate where the root cause of that problem is. If you have a low level of separation of concerns, it's then much more difficult to work with troubleshooting in the product. So that's some aspects of product testability. The second extrinsic factor is about test organization. And to give one example, one participant at the focus group said that, well, we optimize the test environment for the organization, not for the product. So that affects how how good they are for testing of the actual product. So that also affects the quality of the product when it reaches the customer. So it's about the organizational structure and responsibility for the test environments, ways of working, who does what, and also competence. How much competence do the testers have of how the test environments work? And one participant at the workshop even said, we have 3 problems: competence, competence, and competence. The third factor is about business strategy and how the business decisions in the company affects the test environments. It's about your business model, your feedback loops. If you go into more continuous deployment, that affects how much testing must be done and which kind of testing. And it might be that you can have contradicting business decisions. For example, you can have the decision that you should work together with your business partners and test together in your test environments. But another business decision could be that you should, you have promised your customer, based on what industry segment you work in, that you promised your customers that you should not share the same data with others. So you can have contradicting business decisions. So the extrinsic success factors are then product testability, test organization, and business strategy. We found that in successful implementations of test environments, it's a certain order of how you should work with these factors. First, you should work with how you support your company's business strategy, test organization, and product testability, which is then the extrinsic success factors. And then, based on that, you can optimize your test environment capabilities, usability, and stability, which is then the intrinsic success factors. So if you just work with the left-hand side factors, the intrinsic factors, or you start with them, it's much more difficult or even impossible to implement a good test environment. In the study, we found that challenges in the test environments are to a great extent related to hardware systems, even for the companies in the study, which all identify themselves as software companies. So even after migrating to cloud solutions, test environments are still depending on hardware, on specific hardware, but the level of abstraction can be higher or lower. So what we found is that there is no such thing as pure software. There's always a hardware dependency when it comes to test environments and testing. We also found that test environments must be seen as a vital part of the continuous integration and delivery pipeline. And in the same way that these pipelines evolve as you add new test cases during development of your product, you must also add changes, make changes continuously to the test environments in the same pipeline. And as it seems, a clear responsibility for this task seems to be crucial for a successful implementation of test environments. So if you work with this in a good way, the testers, your stakeholders say that this is a good test environment, otherwise you are not as successful. Okay, so it's time for summary and takeaways of this talk. What have we said today? We talked about this list of intrinsic and extrinsic success factors that we identified in this study. The intrinsic success factors include characteristics and capabilities existing within the test environment. And that's, for example, the capability to test cybersecurity. The extrinsic factors are prerequisites that are also important for the test environment, but they're not inherent to the test environment. That could be, for example, the bug information exposed by the system under test. And in order to successfully implement a good test environment, you must both work with the characteristics, capabilities within the test environment, but also influence other parts of the organization to work with the extrinsic success factors. And there's also a certain order in how you must work with these factors. And we found that successful implementations of test environments, they must start with working with how you support the company's business strategy, test organization, and product testability. And based on that, you can optimize your test environment capabilities, usability, and stability. We found that there is no such thing as pure software when it comes to test environments. There's always a hardware dependency, even if the level of abstraction may be more or less deep, for example, if you migrate to cloud. And finally, we found that test environments are a vital part of the continuous integration and delivery pipeline. So in the same way that you frequently update the pipeline with new test cases as development evolves, you must also make changes continuously to the test environment itself in the pipeline. Okay, and that concludes my talk, and we can switch over to questions.